Hello, everyone, and welcome to today's presentation on building an open source security operations center. I am beyond excited for this webinar, but before we begin, I want to let everyone know that we will perform a Q&A at the end of this session. So feel free to use the Zoom control panel at the bottom of your screen to ask those questions at any time. Furthermore, we'll be sending out both the slides and the recording of this session via email later this afternoon, shortly upon conclusion. So you can always rewatch at your convenience whenever you'd like. So today, my name is Chris Mitchell, and I'm a marketing manager here at Siemplify. And I am joined by Arnaud Loos, who's a technical account manager with over 20 years of experience. Arnaud is going to be walking us through how to truly build an open source SOC going beyond the kind of,
the default.
Yes, and into the real life examples. So with that, I'll kick things over to you, Arnaud.
Thank you so much, Chris. I'm excited to be here as well. Thank you everyone for joining today. I'm excited to present this to you. This is a topic that's near and dear to my heart. So as Chris mentioned, my name's Arnaud Loos. I'm a technical account manager here at Siemplify. I've been at Siemplify for almost a year now. And prior to that, my career has spanned being an administrator, an infrastructure engineer, a jack of all trades, so to speak, which has really allowed me to play with these various technologies over the course of the past 20 years. So with that said, I've made my little sacrifice to the demo gods today. May they look down favorably upon me for the next hour, and we will go ahead and commence. All right. So moving on down to the stack that we'll be discussing today. Some of you may have viewed the video that I filmed back in February, a short little video introducing some of these concepts and how they all work together. This webinar will be an extension of that, digging into them in a little bit more detail and actually viewing them in a live environment. So with that said, I'm calling this stack the open source SOC, and really it's meant to be presented as a baseline stack that is available to all. Most of these, if actually all of these products, benefit from many years worth of revisions. And obviously their strength, other than the price, is really that it's a very modular and versatile stack that, while this can be used as a baseline, any of the components can be replaced, swapped out with other products, commercial versions, other open source products, or really just added on to by adding in more alert sources, detection sources, and things of that nature. The goal here is really then to go ahead and map the different products to the current needs that we have within the network and the environment, and then just implement those parts that we deem are missing or as appropriate. Our goal here is really just coverage and insight, and along with discussing the gaps and mapping products back to our coverage and our detections, we'll be discussing the MITRE ATT&CK framework here a little bit later. Some caveats with regard to the stack is not everything that you're going to see is currently architected at scale. This is running in a lab, but all of these products can, of course, be extended out to scale. A quick note here also as I discuss some of the various products. One is going to be that I've omitted Wazoo, which I discussed earlier on, or when I did the original video back in February. The main reason for this is, although Wazoo does cover a nice niche that is not completely overlapped by all the other products available here, I'm omitting it due to its current lack of ECS support. And ECS would be the Elastic Common Schema, the schema that we're going ahead and adhering to as we store all of our documents and indexes inside of Elasticsearch. That doesn't mean that with some additional work, it could not be made to work. I can envision a way of duplicating the indexes that are created, re-indexing them, renaming them so that they're ECS compliant, so that we can go ahead and incorporate the Wazoo agent into the stack. That would be especially nice since the Wazoo agent does natively use Elasticsearch on the back end. But for the purposes of this conversation, I've gone ahead and omitted it. Excuse me. So as we look through here, I'm really trying to touch on all of the highlights that are needed within a SOC, or really within an enterprise network, or possibly even a home network, depending on how ambitious you are. So currently we're going and centering a lot of this around Elasticsearch and Siemplify as well. And really just Elasticsearch in terms of being the SIM here, what we're able to ingest into Elasticsearch, index, and search through. And then some additional products such as Cuckoo Sandbox and MISP, which are really utilized more during the course of an investigation after the alerts have been received and processed. The only caveat I would like to say here is that we'll be seeing Teapot, which is the honeypot that I deployed a little bit later. Deploying a honeypot would traditionally probably go inside of your network or perhaps in the DMZ. I chose to go ahead and throw mine on the public internet so that we would have some interesting data to look at. The DMZ in my lab environment was not very exciting. But otherwise, as opposed to that being a one-off, I have the other products here working in conjunction with one another. I'd also like to go ahead and state that really what you're seeing in this stack is, for the most part, the default configuration. I've done a little bit of customization inside of Elasticsearch, but the deployment of the majority of these products is really in accordance with their default configuration and what you get out of the box. So moving on. The first question is arguably, is this a practical stack? Just because it's available to us, does that mean that we actually want to deploy it and that it's useful? So to that end, I recently came across an article here based on the most recent DEF CON OpenSOC Blue Team CTF. This is a write-up by one of the teams that made it to the finals. They did not win ultimately, but they were one of the top scoring teams. And throughout the post, we've gone ahead and they've added a couple of highlights, 4 tips, in fact, that I've gone ahead and called out here. So the first is really the stack that they're using. And obviously it's a little bit different here. They centered in on Graylog, Moloch, and OSQuery. OSQuery is a part of our stack. Moloch is really used for PCAP indexing and searching. That component's been replaced in our stack by the use of Packetbeat and Elasticsearch. And then really Graylog as well has been replaced by Elasticsearch, just in the easeability of carving up the logs and pulling out the data that's really relevant to you. Moving on there, we also see they focus in on Sigma, an open source rule set, as well as the MITRE attack matrix. And then they really advise that you attempt to use real world scenarios. As we go through some of the testing methodology later on in the slides, there are a lot of, there are methodologies and commands that you can execute on the endpoints to go ahead and track detections. But if you use 100% the pre-canned ones out of the box, it's safe to say that most of the security vendors are familiar with these testing methodologies, and they've ensured that if you copy and paste, their products will in fact go ahead and pass the tests. But the important part is that you're able to then take those as a baseline template, create your own analytics, your own detections, and then really go ahead and try to pivot by using those and simulating more real attacks within your environment. And then, as always, it's important to corroborate across as many data sources as possible. All right. So this brings us to the heart of our stack, which is really using Elasticsearch as a SIM. So the SIM capabilities were introduced in Elastic as beta back in version 7.2 around July of 2019. And Elastic being a company that does frequent feature releases, we've seen this product evolve rapidly throughout the last few iterations since then. The current stack being 7.9, which was just released back on August 18th. And the evolution, while not a complete list, has roughly gone from beginning with some visualizations to go ahead and call out existing data, to really adding in detection rules, machine learning jobs for anomaly detections, and now more recently with the addition of EQL, the Elastic agent, and then we'll see what is yet to come in the next version. Some of the highlights of Elasticsearch and some of the benefits that you really get out of the box. The first is the utilization of the Elastic Common Schema. And this kind of lies at the heart of everything working within Elastic. And not only within Elastic, within Kibana as well. That being said, all of the visualizations that come out of the box, all of the machine learning jobs are all written with the expectation that the log sources will adhere to the Elastic Common Schema. And so that's really where the magic happens behind the scenes. And as analysts and engineers, it behooves us to make sure that as we're ingesting our data into Elasticsearch, it does adhere to the Elastic Common Schema. Discuss that here in a little bit more. And really now, Elasticsearch, by virtue of being able to pump in data from pretty much any data source that you're able to imagine, we get the ability to go ahead and combine logging, metrics, APM data, everything together to add to greater observability within the stack. And while some of these may not be used necessarily as detection sources, throughout the course of investigating our alerts, they do in fact come in quite handy. It's important to note that alerting has a different connotation within the stack, that within the SIM, our alert rules are called detections, and really alerting is something that is available throughout all of the different products included in the stack, all throughout the different areas of Elasticsearch, but is really a little bit different than the detection rules that we're going to be discussing with regards to the Elastic SIM app. So the Elastic SIM app itself comes with some nice capabilities. For example, IP reputation links. These are customizable lookups to something like a virus total to go ahead and do a little bit of lookups from within the GUI throughout the course of the investigation. There's obviously, as we're going to discuss here in a little bit, additional ways to filter and enrich as we're ingesting the new information through our ETL pipeline before it's stored in Elasticsearch. And then with regards to the SIM itself, we currently stand at approximately 28 machine learning dedicated anomaly detection jobs that are purely SIM focused. That being said, the ML jobs are something that are a paid feature within the product, hence the asterisk next to that bullet point. And we're currently stand at about 200,000 pre-built detection rules, which are also mapped to MITRE ATT&CK tactics and techniques, along with pre-built visualizations, both within the individual beats themselves that we're able to load up, and then also with the SIM app itself. One thing that Elastic does make available is that a lot of their code resides on GitHub. And so the two links that I have at the bottom here are really just a change log of the rules as they're being released throughout the different versions. And then also the ability to go ahead and look at the repo within GitHub where community members can go ahead and submit future rules as well if you want to get a little bit of a pre-release version of what's possible to come and what others are working on. I also wanted to go ahead and provide as guidance this blog post, which is from this month as well, up on the Elastic blog. And this is really a discussion from one of their B-Sides events on how to execute a threat hunt within Elastic from beginning to end. I found it a very good read. And speaking specifically about what has become most recently available within the past 2 weeks with the most recent release of Elastic, the most notable, and this has been a big release, is really the ability, the introduction of the Elastic agent and the capabilities that it introduces. The way that you now manage integrations and configurations, the way that you're able to centrally manage and deploy them and then centrally manage them within the new Fleet Central Management. These are rich capabilities often found in many other products that Elastic has chosen to make available free of charge. I do want to note that within everything that you're viewing today, my Elasticsearch node member, everything is running under the basic license. There is nothing behind the scenes. And we'll be able to see all these capabilities live within a demo. And really the important part here is that whereas Elastic, the company, has been pushing the beats agents as a method of data ingestion, or many methods of data ingestion, the complexity around managing many beats at scale is a little bit problematic. And hence the reason that Elastic has introduced this Fleet Central Management is to not only allow us the capability of not having to manage numerous beats agents. A lot of that functionality, or all of that functionality, is being combined under a single Elastic agent that's able to be deployed, and then managed through the Fleet Central Management if you wish to modify or update the configurations. Of note during this presentation is what we will be seeing is I'm ingesting from Windows through a combination of WinLog beat and packet beat. I do not have, excuse me, the Elastic agent deployed. I have another slide on here, but it's currently an experimental release with limited functionality. And I did desire the rich dashboards and capabilities that came along with WinLogBeat, which is why for this presentation, I chose to go that route. All right, this is really just for those, so we're all up to speed on the data shippers that are available from Elastic. These are all the different beats which are available. Beats make it easy to go ahead and ship data from the sources into Elasticsearch from almost any source that you can imagine. It's important to note that many of the beats also include additional modules that extend their capabilities. And one of the big advantages that the beats provide, number one, not only are they a little bit more lightweight, you're able to use beats sometimes in conjunction with Logstash for data ingestion, sometimes in lieu of Logstash. And using beats agents most often comes with the capability of having our data formatted using the Elastic Common Schema, usually with very little involvement on your part. That's not universally true. There are some situations where some manual filtering and massaging of the data is still required, but using a beats will often go ahead and take care of a lot of that work for you. So as I mentioned, really beats they're also a little bit more lightweight than Logstash. Logstash is written in Java, the beats are written in Go, they're a little bit more performant. But they don't always meet all of the use cases. Logstash is still a little bit more full-featured with regards to its filtering capabilities. So if you're able to use a beats to go ahead and ingest data into Elastic, it's recommended that you do so, but it will not meet all the use cases. And that's when really Logstash needs to be deployed. All right, and then discussing the way the Elastic agent takes over from the beats. So really the Elastic agent, as I mentioned before, is a single agent that we're able to go ahead and deploy and configure, currently experimental with limited functionality. Really all of the different beats themselves, as well as the modules that are contained within the beats, are moving to become integrations which are able to be deployed to Elastic agents. And then those integrations themselves can be managed in various group configurations that we can deploy, that we can choose to deploy to various agents themselves. The main capabilities here that come with the security agent is really that it provides both malware detection and prevention for Windows and OS X out of the box. And it also provides very detailed event collection. So for example, in the use case of Windows, we collect network, file process, registry, DNS, DLLs, and a lot of other activity. For OS X and Linux, it's mostly down to the network file and process level, but still a wealth of data that's aggregated into the system. It's important to note that within my setup, I'm using Sysmon on my Windows endpoints to also go ahead and collect some of the similar data. So as I look through my indices, I will see some of this network file process registry information contained as well, but that's being delivered to me through the Windows event logs via the installation of Sysmon. What we can see here on the right-hand side are some of the new capabilities or screens that are available to us through the Kibana GUI. At the bottom, we see various integrations that are able to be installed into a deployment configuration. And at the top, we're able to see a process tree, which for any that migrated from Endgame into Elastic Endpoint Security should be very familiar, and then gives another level of investigative capabilities. I'm very eager to see where this is going, where Elastic is going to take this. And I fully expect that over the next few revisions, the integrations will go from being experimental to fully accepted, and the number of integrations to be built out to the point that it overlaps one-for-one with the current beats capabilities. Obviously, I understand that's a large lift and shift, but excited to where it's going. Another capability that comes to us or is introduced to us in Elasticsearch 7.9, which is also some might be familiar with from back in the Endgame days, and that is the EQL, the Event Query Language, which is a query language for event-based time series data, such as logs that are being fed into Elasticsearch. Within 7.9, what's introduced is a new EQL API search endpoint that we're able to leverage. You'll see an example of that on the bottom right. So Atomic Red Team, which is a testing framework that we're going to get into here in a little bit, gives an example on their page of executing a command to go ahead and look for a specific technique or a technique available within MITRE. The way we would look for that as the equivalent EQL search, you can see the syntax down here below. Now, really, there's a couple of components that are required in order for EQL to work. Mostly that's a timestamp, as well as an event category field. The event.category is ECS compliant, although you do have the ability to supply a different category field should you not be utilizing ECS. And really the format is that it requires an event category and a matching condition and possibly some keywords, pipes, and other functions to go ahead and join the data together. You can see here an example of what that would look like, as well as some links on the bottom with regards to the new capabilities within 7.9. Another link that I wanted to provide was directly to the GitHub that discusses the full implementation of EQL within Elasticsearch. I know that this is just the first phase of a wider planned rollout. But if you wish to see where Elastic is with regards to the actual rollout of this EQL feature, this GitHub link will take us to the milestones that are listed. Now, EQL provides some enhanced capabilities in finding detections and writing detection rules and threat hunting within the product. In the current implementation, there are some limitations that have not yet been implemented. And really what I expect is the detections that are within the platform, the pre-canned detections, are not currently written using EQL. They're still currently written using the KQL language, but I also do expect in the future that as EQL becomes full-featured within the platform, we'll be able to utilize those capabilities for detections as well. Moving down just for a second to really try to showcase the power that EQL is going to bring within the platform. These are some examples of some EQL detections or sequences that can be written to go ahead and find some specific alerts within all of our events within the platform. Tracking an RDP logon through some network and event IDs within a time span. Looking for files that were created but are not owned by the same owner, detecting suspicious shells. You can see not only the queried syntax of the language itself here, but also the capabilities that it provides in looking between time spans, joins, and all of its other capabilities. I provided a link at the bottom for those that wish to go check out a library of additional detections that have been made available on the platform. All right, I see I'm at 25 after the hour. So moving down off from the Elastic Stack into the other components that we have as part of our open source stack. So the first capability that we're going to discuss is the IDS, which is brought to us by Suricata and Zeek, formerly referred to as Bro. As I alluded to before, really my installation is a default installation. I did not want to go in depth into what that looked like. There's numerous guides that are available on the internet. I will say that after looking at the versions that are available in the various distribution repositories, I chose to go ahead and install from source. I would recommend that route to others as well to get the latest and greatest. And the biggest roadblock that you'll run into going that way is really making sure that you have all the dependencies installed beforehand. But yet again, numerous deployment guides available on the internet that call that out. Suricata can be installed both as an IDS or as an IPS. Uses IP tables. If we want to use the prevention portion, I've gone ahead and installed it as an IDS. And then some general recommendations is really to turn off any packet offload features on the network card on which Suricata is listening on. From there, it was a matter of reviewing my Suricata YAML file, go ahead and running it manually. You can create a service file to go ahead and obviously start it up automatically. And then all of my sources, which are loaded, were all the default sources available within the platform. And you're able to manage those with the suricata update command. And I've gone ahead and listed the first two suricata update commands that should be run here, along with enabling a single source. Whenever you go ahead and you run the list source command, there will be many additional sources available, which can be installed as well. The number one tweak I then did after that was looking into disabling really the noisy rules. Excuse me. And then really for additional testing from that point, they also make some public data sets available in terms of PCAPs, and you're able to not only listen for live traffic, but also go ahead and push pre-structured PCAP files through Suricata in order to go through the detections as well. So I did want to take a second here as we're going through some of these products to really, actually, let me go down to my next slide as well on Zeek, and we can look at both together within the platform. So the other IDS that I have running on my same box that's running Zeek, or that's running Suricata, is Zeek. And Zeek I also installed from source for the same reasons. This is one that anyone that's been looking at IDS solutions over the course of the past 20, 25 years must have come across. And yet again, it's really just the default installation out of the box. Zeek goes ahead and creates many different log files for the traffic that it's able to categorize. Those log files by default are stored in a format which is not the format which is ideal for us to ingest through FileBeat. Elastic has a wonderful article on their blog on some of the modifications that are necessary in order for us to go ahead and begin working with this data. And really that's just enabling the output to be JSON so it can be more easily ingested. Once it's deployed, you utilize the Zeek control module to go ahead and issue a deploy command, which will start up the services in the background and begin analyzing the traffic. There are, if you're looking to do this at scale, some performance tuning libraries that are recommended to be implemented. I believe Zeek has said that there are installations that are running at 10 gig, if not even also 100 gig, which they're able to keep up with. It's definitely a product that is scalable. And really, it's important to note this quote from off their website, that it's not a classic signature-based intrusion detection system. It does support that functionality, but it also includes a scripting language that really facilitates a broader and deeper spectrum of different approaches to finding malicious activity. I give a link at the bottom here to the script repo that provides some examples. Really, the logs, the conlog, DNS, every log that is output by the system is output through one of the scripts that are currently implemented within the system. And then you obviously have the ability to go ahead and write your own for additional detections. Either that, or you can also visit the packages repository to easily install what others have already created. I just wanted to take a second to go ahead now and actually log into the platform and demonstrate what this first alert source looks like from an ingestion medium. We'll give this just 1 second to load as I see that we have a question. What skills, knowledge do you think are needed to integrate all of these components together? So from an infrastructure standpoint, the different products, it all depends, right? There are some that we'll be getting into a little bit later, which are easily deployable through package repositories and merely require opening up a config file in order to do some baseline changes necessary for your environment. That's also a methodology that you can use to install Suricata and Zeek. You can go ahead and install from the repositories available on all the major Linux distributions. You will probably not get the most recent version that is available, but you will get a working version that includes the rule sets and much of the capabilities. From that standpoint, it really is a matter of going into usually one config file, determining what your home network range is, which detections you wish to enable. And there's really not much else that's necessary after the box. That will get you what I call a default installation, but then obviously much of the power of these comes from extending them out, either through your own capabilities and writing additional detections and scripts, or possibly as well through utilizing some of the community ones that are available. With regards, and I also want to note that many of these packages can be deployed together on the same box. We will look a little bit later at pfSense here, which I'm using as the firewall component. pfSense also includes a package repository, of which Suricata is one of the packages that you're able to install. So whereas even the pfSense deployment itself is very easy, booting off an ISO and following a wizard that's on the screen, even after the fact, since you already have now one machine by virtue of being a firewall that your traffic will travel through, deploying the Suricata package on top of that and now adding in an IDS on top of your firewall is even more trivial than just deploying it from a repository on your own. So I will say that depending on how far you wish to take some of these, some institutional knowledge and domain-specific knowledge in these products will eventually come as part of the learning curve. But as stated before, what I have running here and what you're able to see in my environment is really the default out of the box that took very little to deploy. So first thing I wanted to note over here within Elasticsearch is that I have a number of sources feeding into a number of indexes through a number of beats within my lab environment. For the purposes of Suricata and IDS, which I have running on a single server that is located within my DMZ on a span port off my pfSense firewall, I'm collecting those using the built-in modules within FileBeat. And we'll be able to see here as I go ahead and I pull these up that I have event data sources that are coming from my Suricata Eve log and then all of my different Zeek logs, which I only have chosen to include a subset of the ones that are available. Zeek will go ahead and break down the traffic into many different logs. And then as we're able to see here, I have all of my fields nicely parsed and correctly named according to the Elastic Common Schema, with no additional work necessary on my part. Just because I was able to go ahead and utilize the modules that are available within FileBeat, it went ahead and did all of the renaming for me with no additional work. Okay. So really this, for the time being, is all I'm going to show is having this data really feeding in through my FileBeat and properly parsed and indexed within a FileBeat index. As we move on here through some of the other products that we have integrated in our environment, I'm using MISP really as a threat intelligence source. For those of you not familiar with MISP, it is a product, an open source threat intelligence platform that's been released by Circle. Circle is the Computer Incident Response Center of Luxembourg. And its primary purpose, it started out really as being meant to share malware indicators between organizations and has really evolved to incorporate all kinds of different IOCs and now through their galaxies and other add-ons as well, even data that's structured not in the same format as an IOC. Its main purpose is really for categorizing different IOCs, but then also facilitating sharing those with different organizations, be those departments within your organizations, different trade groups, or community groups that are available as well. It does so through the traffic light protocol. In our instance, really what I'm using MISP for is really purely as I subscribe to some feeds, pull in indicators of compromise, and use it as a threat intelligence platform to do lookups from. It has obviously very extensive capabilities beyond that, where we are able to generate rules for various products, for example, Snort, Suricata, Zeek, from within MISP as well. But I'm not currently using it within the scope of this webinar for those capabilities. This is, yet again, a very simple deployment. And I can show right now really what is necessary in order to complete this deployment. Mine is deployed using one of their pre-canned VMs, which they do not recommend for production. But it does simplify the deployment greatly. Ah, wonderful. I think I left my page open too long. So just a couple of quick points regarding MISP. Whenever you do go ahead and deploy it, if you are having issues, I first recommend coming over and investigating your workers and making sure that they are all healthy. If you happen to see a banner across the top of the page that says the server is not live, you'll want to go ahead and set the MISP.live setting equal to true. You can do so just by double clicking. And then I would also recommend coming down here and disabling the email as well. After that, it's really a matter of coming in. You can look at scheduled tasks. They're all set to 0 by default. I recommend automating the fetching of the feeds. And then really it's a matter of coming down under the feed list and choosing to go ahead and add some of those. MISP does go ahead and provide quite a few feeds that you're able to add in through this URL that I have located at the bottom. It's incredibly easy to do so. And once you've done so, you can go ahead and hit the blue button to fetch and store all feed data. And then on the home page, you're able to go down to list attributes and see all of the IOCs that are being pulled in. And now really that's all that's necessary to make it a threat intelligence source. Now under list users, you can see that we have an API key that's available. That's really what's necessary in order to connect. And now we can go ahead and issue our queries through its API in order to go ahead and pull back the information that we're looking for. See, I'm getting a little short on time, so I'm going to move through some of these slides here. pfSense, the firewall that I've chosen to go ahead and deploy, touted on their website as the world's most trusted open source firewall based on FreeBSD. There's a number of other options, some of them even being forks of pfSense that are available to us that I have listed here. But pfSense I've found has always met my needs, and so that's the one I've decided to stick with. It does have a built-in package manager that can be used to extend the platform. Suricata is one of the available add-on packages available, as I discussed before. And really the way that I've gone ahead and I've collected this data is through a syslog listener being sent to, in this case, Logstash or FileBeat with the syslog module. And I've provided a link here to somebody else's GitHub repo, which is really the filtering that I'm utilizing to go ahead and carve out the syslog data. It's important to note that if you do choose to go with pfSense, they do have a commercial arm that does provide hardware and professional services as well. For those of you who are unfamiliar with pfSense, I can show you what the interface looks like here. I have 3 network cards attached to my virtual machine, my LAN, my WAN, and my DMZ. I've gone ahead here, I've created a bridged network, which really just goes ahead and bridges my 3rd network card to my LAN, which gives me the ability to go ahead and sniff all of the traffic for my IDS. And then regarding the firewall itself, easy to configure in a recognizable format, especially when your firewall has default rules of allow all in every single direction, which I do not recommend for production use. Otherwise, we're able to go down here to the package manager to go ahead and extend out the platform. And we're also able to go down to system logs. Under system logs, we can see under settings, all I've done to go ahead and send this data out to my listener is enable a remote log server. And I've chosen which logs to go ahead and forward, only a subset, as you can see here. I'm then utilizing the Logstash filter that I've included in that link, which results in me getting now my logs listed over here. An important part regarding an approach that I've chosen to take with regards to these logs and the way that it's currently implemented. And this is something that really kind of showcases the versatility of this stack and how with a little bit of creativity, you're able to go ahead and extend it out even further beyond the default. So obviously, on top of being able to ingest data, the ELK stack is also able to go ahead and process it in flight to modify as needed. We're able to go ahead and do so through a Logstash filter, and we're also able to do so on the Elasticsearch side if we so desire. Now, due to the open nature of these products, this has enabled me to go ahead and design a workflow that allows me to actually load up malware IOCs right into Elasticsearch. So this is sample code that I'm providing. You can see here, we go out to malware domain list, we go ahead, we parse the results, and then all I do is essentially write them as key value pairs into an Elasticsearch index. This is one method through which I would then be able to use an Elasticsearch ingest node to further enrich the data in line. Or I could go ahead and actually choose to move this over to the Logstash side, that instead of loading that malware data into an Elasticsearch index, I can decide that I want my processing to take place on a separate node, which is running Logstash. In this case, I would probably choose the memcache filter. I could go ahead and install memcache on the same server as Logstash, load up a key value index of my malware IOCs, and now do very fast filtering and inline comparison against that source so that I'm able to determine if my malware logs contain anything which I would be interested in being alerted on. If I don't do this additional step of being able to compare that source against something else, then really that data serves as contextual data during the course of an investigation and a threat hunt. If I already have an indication as to perhaps which URLs or which hosts I'm interested in. And really, this is just one sample workflow that's meant to illustrate the versatility of the stack. Going down, I've implemented Cuckoo Sandbox as a sandboxed VM environment to really go ahead and analyze file execution and URL detonations, as well as network calls. This is not, I'm not currently pulling back any of these logs through any of the Beats agents. This is a component that I'm going to showcase here in a second through a Siemplify workflow to do inline enrichment. Deploying Cuckoo can be a little bit problematic at times. So I went ahead and linked to an automated deployment of somebody's GitHub here. And then to note that there are signatures and contributions that are also available through the community itself. For those of you who wish to see what Cuckoo Sandbox looks like, this is it right here. I'm able to go ahead and submit files and URLs right here through the web interface, but I'm also able to do so through their API. Once you go ahead and you execute a detonation, you're able to view the results down here, as well as go into the details. And the details include a risk score, which we can see here has been 4.2 out of 10. Details and classification of the observed behaviors, as well as some screenshots of the execution as well. And I'll show that here in a second in a playbook that I have within Siemplify. Moving on down through the stack, OSQuery really is a very versatile product that is able to be deployed on almost every device and operating system where you would want to deploy it. And it utilizes SQL commands to go ahead and pull information back in a structured manner from all the different devices, useful for inventorying, forensics, scheduling of gathered information, compliance, and such. You're able to go ahead and run it through the utilization of the OSQuery I interactive shell. And then you can pass it commands in what is seen as SQL syntax with select from statements. You're able to go ahead and set up queries if you wish to generate logs to go ahead and pull this information back into Elasticsearch, or you can query on demand as needed throughout the course of an investigation. It's also important to note that at the bottom here, we can execute one-liners by echoing statements into the interactive shell, and we'll see how that's used here in just a second. Two related projects would be Fleet if you want to manage your OSQuery deployments at scale, as well as Stream Alert, which is a recent project I've discovered from Airbnb, which allows you to generate alerts from the data that you collect through OSQuery as well. Discussing our framework for testing here, and really a big part of this is mapping what this product stack gives us in terms of our detection capabilities. Where does it give us coverage? Where does it not give us coverage? To that end, Atomic Red Team is a testing framework that enables us to go ahead and do some of that mapping. I've provided links here that go both to the main testing page as well as a repository of the atomics that they provide. And our goal in utilizing this testing framework is to execute tests, collect evidence, and really measure progress. Map out of the tests that we execute, which did we detect, which did we not detect, and how do we have to shore up our product stack or our detection rules in order to detect what we missed. These are all mapped back to MITRE ATT&CK. There's a link here that shows a Windows matrix of some of the detections mapped back to tactics and techniques, and an example command here of an atomic that would be run as a singular test on an endpoint. You're able to go ahead and just clone down their repository to all of your endpoints. There is a framework called Invoke Atomic, which is a PowerShell framework for invoking the tests. There are other frameworks for other operating systems. And you're able to go ahead and invoke individual tests, or if you want to watch your sim light up like a Christmas tree, you can just use the Invoke Atomic Test All command, say yes to the warning that's presented on screen, and watch it commit every test that it has. If you're interested in doing so from a GUI, they also provide one of those. And then ultimately, all of this is being mapped back to the MITRE ATT&CK framework, because it's important to not only go ahead and implement products within your environment, but to go ahead and map the capabilities of those products to a framework so that you know what your current stance is. I'm sure most people here are familiar with the MITRE ATT&CK framework and the pyramid of pain showcased on the right-hand side. But really, MITRE ATT&CK is meant to tackle those TTPs, right? The very top of the pyramid. The behavioral analytics, which is a little bit harder to quantify through a more automated fashion, although MITRE has done an excellent job of quantifying these tactics and these techniques. Really, MITRE is used for 4 key points: adversary emulation, assessment, detection, and analyzing threat intelligence. This enables you, as I alluded to the slide earlier regarding the DEF CON 28 participants. They recommended really real world testing. And this is where you're able to use red teaming techniques and writing your own techniques in order to test internally. Go ahead and mapping your products back to the attack navigator to seeing where your coverage lies, either through the attack evaluations that MITRE makes available on their website, or going through the process of mapping the techniques yourself. As well as a confidence score on your ability to go ahead and detect the specific techniques. This is really the methodology for going through validating your defenses, identifying the gaps in the defenses, and spending your money wisely in ensuring that you're adding on to your stack by utilizing products that are giving you visibility into the areas where you currently have gaps and not do too much overlap with your current capabilities. And I highly recommend a video provided by Andy Applebaum on attack-based SOC assessments, the link of which I've provided at the bottom. And really for the important part here is that the attack navigator that we see on the right-hand side covers the tactics across the top, which are the whys of what we're going to do, and then the techniques inside the attack navigator, which are the hows of how that's going to be accomplished. And really by mapping our defenses to all of these capabilities, we really do get a better assessment of where the SOC stands. And last but not least, as I'm running out of time, as I said, I went ahead and deployed Teapot as a honeypot. Teapot is actually an aggregation of about 18 or so Dockerized honeypots, utilizing Elasticsearch as a backend with some very nice Kibana visualizations at the front to see who it is that's targeting you. Ideally, yours would not look like mine with thousands of attacks discovered within a span of minutes or hours, but when placed in the DMZ really serves as an alert source, because nobody should know of the existence of these honeypots, and so nobody should be purposefully touching them. And lastly here, before going into the quick live demo, I wanted to show some or give some additional recommendations specific to Windows domain and security. Our detections along this front really determine on pulling in the necessary information to provide the events that we can search across for the alerts that we're looking for. I'd recommend within a Windows environment, go ahead and adding in some additional logging capabilities. This includes generating event 4688 for command line logging, some PowerShell module logging, as well as enabling sysmon with a verified configuration to do more of the DNS, DLL, network type event collection that I discussed before. Along with that, I've listed out some additional open source tools that may be of benefit. And then very lastly, going into really where we stand here with regards to the network architecture as I've set it up within the lab. I've got pfSense running as my firewall, sending syslog, mirroring out on a span port all of my traffic to my IDS, also feeding logs into Elasticsearch, a domain controller, and then I've got Siemplify pulling in alerts and doing some enrichment with MISP and Cuckoo. So with that being said, I'm going to jump back here real quick. I wanted to give a real world. So this is the teapot that I currently have on a DigitalOcean droplet. This is looking at an hour's worth of traffic. If I refresh here, see what it pulls back, but it's always interesting to see how often you get attacked on the public internet with an unprotected box. Moving back, I really wanted to go ahead and showcase, obviously, very quickly the security app within Elastic and how this information comes through. So here you're able to see the overview page along with all of my detections coming in as the detection rules are looking over all of my audit beat, winlog beat, packet beat. Based on the detections that I have enabled, I'm generating these signal rule names that I can view from here. I'm not going to go into the detections tab right now. We get very rich host and network screens. Should have picked a slightly faster server to go ahead and explore our data a little bit more. In my lab, I don't have very many hosts, so that screen becomes a little less useful, but the network screen looks very rich and interesting, although the map will take a second to load on my machine. The only other part that I really wanted to quickly showcase here that is really outside of the security app is the dashboards and the visualizations. As soon as this finishes loading, we'll get our nice map. And really here breaking down all of our source IPs, destinations, how much traffic, who they've been talking to, all laid out in very rich, nice tables that we're able to go ahead and drill down even deeper into or use to go ahead and pivot to other aspects of our investigations. The other part that I wanted to quickly go ahead and show here are some of the dashboards that become available as you load in some of the beat agents. So I discussed how we had modules that enable rewriting the data to adhere to the Elastic Common Schema. These modules also come with rich visualizations to focus in on the specific data being provided by all of these products. I should have trimmed down my 24 hours there to a smaller source, but it'll load up here. So as you can see here, we get very rich visualizations regarding just our Zeek data. We're able to do the same for Suricata as well. And then I wanted to quickly go ahead and showcase here from Winlog Beat some of the dashboards that are also made available to us. I'm going to go ahead and call out specifically the user management dashboard so we could look at that just for a second. And I went ahead and added some users over the course of the past 24 hours, did some password resets. If I were to go look at the group pane as well, we would see all of my group memberships and additions. In order to just quickly close this out as I get to my tab, I very quickly wanted to showcase what this looks like from within Siemplify. So I have a connector set up over here, Elasticsearch. We can see here that I'm using from the signals that are generated, some of the new signal fields as my alert name field and my event field. I'm using the agent type as my product. I'm able to go ahead and pull in various alerts, which depending on which fields I've chosen to use, come back with cases created within the platform. Now, I went ahead and created a mock case here, a manual case to go ahead and showcase some of the items. I added in a malicious URL, source and destination IPs, host name, username, and a file hash. To that, I went ahead and added in a demo playbook that calls out a lot of the features that we've discussed today. And we can see really that as we're going through the platform, actually, perhaps I'll go to the case wall screen instead to showcase some of this. we can really see here, and I'm not going to click on it because it's going to load a lot of data, that we're pulling back these indicators of compromise from our threat intel source. We're able to go ahead and see our detonations within Cuckoo, do our Active Directory enrichment, go back and do some additional searching within Elasticsearch based on some of these entities that we've called out. And then the last kind of neat one that I wanted to show here was I wasn't able to show OSQuery in practice, but I've gone ahead and pulled back OSQuery results through the running of an SSH command. And if I just go look at the playbook that's associated with this real quick, we'll see here that I'm just running a very generic SSH command in which I'm passing the one-liner that I showcased before. And so I've gone ahead and used my echo statement to echo into OSQuery in order to get my results. And I get back both JSON and table results, which comes through as the view that I showed on the case there. But this gets us through utilizing all the products as either alert sources to ingest into Elasticsearch, or then following up on our investigation through the subsequent products that we have in our environment. It seems I was able to speak for about 57 minutes straight there. And so I wanted to go ahead and open up the floor now to any questions that anyone may have.
Awesome. Thank you for the presentation and demo, Arnaud. Just a reminder to everyone, we're going to jump into the Q&A now, so feel free to use the control panel at the bottom of your screen to ask those questions. Also, another reminder, because we've been asked this a couple times already, we are recording this presentation and we will send it out via email upon the conclusion of this session, along with a copy of the slides as well. But jumping into the Q&A, someone would like to know if Elasticsearch works as a full-fledged SIM and if it supports 200K EPS.
200K EPS. So the first thing I will say is that Elastic is known to scale very well. Whereas perhaps the SIM and security capabilities are new, ingesting vast amounts of data from numerous sources has been one of Elasticsearch's strengths going back for a number of years now. And so while I don't have an exact answer to the 200K number, I would hazard a guess that that Elasticsearch is scalable to that level of events per second. And then the first part of that, I believe, was really its capabilities as a SIM. And to that end, I'll say it's getting better with every single release. Depending on the requirements, you could perhaps put the argument that it's missing certain core capabilities, correlations. We've now included just recently the ability to do threshold detections. So depending on how important those correlations and everything else are, perhaps by the next version or the version after that, whenever EQL is fully situated within the platform, we'll see that evolve a little bit more. But I would say at the very least today, it is definitely far enough along to be used as a SIM. And I believe I'm going to open up the chat section here also, as I see that there's some other comments coming in.
Someone would also like to know if you can deploy this in a multi-tenant model.
So multi-tenant, the answer is it depends. And really, right, in the ideal way of doing the multi-tenant model would be to probably do something like utilize ECS. And the requirement would probably, or the recommendation would probably be, if you're able to do so, turn up a small cluster for each client or each environment in order to go ahead and isolate the data. You also have the ability of just running one big cluster and pushing data from various clients into one large cluster. The ability to set permissions down at the index level is, however, a paid feature starting at the gold licensing level. So if you plan to expose that data to anyone who needs to be secluded and should not be seeing other clients' data, then you would want to at least apply a license and go ahead and apply granular permissions. If you're running your Elasticsearch cluster in the back end of your data center with multiple layers of security on it, and only analysts that are already allowed to look across all environments are the ones that are accessing it, then you could also perhaps utilize it in a multi-tenant model with just the basic license applied. But really, to do it at scale or to do it at production, I would recommend using ECS or having granular permissions on your indexes.
Cool. Another question that I can help address here is someone would like to know what the difference between the Siemplify Community Edition is versus our commercial product. And there's just a few differences, including the number of users, the maximum amount of daily alerts that we ingest, as well as the maximum number of playbooks that you're allowed to create and run. I think the community is a great place to get started. And then obviously, as you scale your operations, you know, we can make sure our platform scales with you. So that one, so many questions.
I'll let you go ahead and dictate the order.
So I know a lot of people have mentioned a couple different things, but can you just speak to if they have an existing solution, whether it's checkpoint, firewall, or something else of that nature? Can they plug those into this model as well?
So I'll start off by saying pretty much any data can be sent over to Elasticsearch. Regarding specifically kind of, if I approach this from a plug and play architecture, which is really doing all of the ECS field naming in a nice automated fashion, you're now a little bit dependent on either other people's work or what the beats offer you. So if first of all, if there is a beat, or if one of the beats has a module that corresponds to your product, then it's very clean and very easy. Depending on some products and how you choose to ingest that data, you know, most notably in a SOC environment, if you're sending over syslog data, which is in a, let's call it a somewhat simple CSV syntax, you'll need to do additional parsing and possibly spend some time on a filter that goes ahead and does ECS renaming for you. But you're able, right, you can also do with ECS, there's also levels at which you can implement it, right? There are a certain number of core fields that you would definitely want to make sure you map from the beginning. The source and destination IP addresses, host names. There's a few core fields on which the ML jobs and a lot of the visualizations are based. So you could start out by just doing the renaming of, let's say, a dozen or so fields, and leaving the rest, and then gradually going through and reiterating over your deployment and doing gradual improvements. And there are people also, right, there are people that have paid SIMs that are continuing, but where it costs money, right? The more data you store in your SIM, the more money it possibly costs, or the more resources it takes. So a lot of people also turn up Elasticsearch side by side with their current SIM as either a place to put additional data that's not going to the SIM for one reason or another, or as the beginnings of a migration process of moving from one SIM to another.
Cool. Another question, someone would like to know how they can achieve and prove compliance with this stack.
That is a difficult question that I am probably not qualified to answer. I might have to punt on that one. I believe there are some persons from Elastic on this webinar if they would care to chime in, but I don't have any specific advice regarding that. Okay,
forgive me.
They can all, right, and obviously they can also reach out to Elastic as well.
Yep. Can the IOCs and Intel artifacts gathered through investigation be automatically correlated with incoming logs and alerts?
Read that one more time.
Can the IOCs and Intel artifacts gathered through investigation be automatically correlated with incoming logs and alerts?
I'm going to avoid using the word correlation, but they can definitely be harnessed against one another. So we're able to do, I showed the methodology before of pulling IOCs pragmatically through the API out of MISP. Actually, I didn't do it through MISP. I showed pulling from malware domain lists specifically. One thing that I have done in the past is you can actually utilize tags very liberally within MISP. And I've pulled out IOCs that I have tagged into Memcache specific. So I wouldn't call that correlation. You can do inline enrichment utilizing MISP IOCs, and which would then, and you could also go ahead and utilize the IOCs within MISP to generate Suricata, Zeek, Snort, new rules that would trigger alerts. And so you would be able to discover them that way, but not correlation in the sense that I'm thinking of the word.
All right. I think we're actually going to wrap up the Q&A there. I know we're a little over, so I want to thank everyone once again for joining us today. As mentioned, if you were interested in what you saw today and you want to check out the community edition of Siemplify, you can go to siemplify.co/community and download it for free from there. And with that, any parting words, Arnaud?
No, I just want to thank all of those that have stuck with me through the end. I was hoping to get done with my portion a little bit sooner, but thank you for staying with us and extending over. And I'd also like to make myself available if anyone has any follow-up questions that I was not able to get to today. My email address is aloos@siemplify.co. Please feel free to reach out.
Awesome. Thank you. And thanks everyone again, and have a great afternoon.
All right. Thank you.